Welcome back, everyone. So, today we are going to talk about three types of concurrency constructs from SystemVerilog in details. So, let's begin. So, those three types are fork join, the fork join none, and the fork join any. So, without any further delay, let's begin with an example. So, I will write a test module in which I will run multiple processes in parallel, and I will use fork join to make them run in parallel. We'll call it test. So inside test, I will write initial block, and inside this, we will write multiple statements. And each statement inside a fork join will be considered as a process. And every process starts together and runs in parallel. So first, let's use fork join. So inside fork join, I'm going to write to display system task. So for the first system task, uh, let's just write the time, and let's call this thread A, considering that uh, each display system task represents a thread. So I will instead write thread A finishes at time t, and then we will use $time. And let's call the other system task as thread B. And again, I will use $time. So here, inside a fork join block, every statement is considered as a separate process, and each of them will run in parallel. But here, the issue is that uh, each of the display tasks does not have any time delay. So both of them will start at the same time and they will finish at the same time. So you could write multiple statements inside a process. And to do that, you need to use begin and end. Just begin and end. So I will show you how. So let's say for our thread A, we want a delay of 10 time unit. So we just have to write begin and end. So whatever you write inside this begin and end will be considered as a part of the same process. So if I write, let's say here 10, so I am writing a delay of 10 time units. And this, since both of the statements are inside a single process, they will finish in a sequential order. That is, first this delay will start, and after when it finishes, this display statement will execute. So same could be done for the second thread. And here, let's give it a different delay. Let's give a delay of 20 time units. So here what is happening, there are two threads running in parallel, and because of begin and end, uh, these two statements are part of this thread, and these two statements are part of this thread. So let's call this as uh, thread A block, and let's call this as thread B block. So what will happen inside a fork join? So it will wait. It will wait for all the threads to complete, and only after all the threads inside the fork join completes, then only it will proceed, and then only the code flow will leave the join. So all threads need to complete before moving to the next line. So let's say outside the join block, we have another thread, and let's call it the main thread. The main thread finishes at time. So as per the definition of fork join, uh, here first both the threads are required to complete first, then only the code will exit the fork join block, and this main thread will be executed. So as per the delay, you could see we have a standard fork join. So as per the delay, thread A will take 10 time units, and thread B will take 20 time units. And because again, this is a standard fork join, the main process will wait for all the threads to complete before moving to line 15. So let's save this code and let's check the simulation results in QuestaSim. So first, I will just compile the code to check whether I have made any typos, and of course to make it prepare for the simulation. Okay, we don't have any errors. So let's start the simulation. Let's run it. So as you can observe right here that the thread A finishes at time 10. So first we started at time 0, and from there it went inside the fork join block. And since we are using the standard fork join, all the threads inside the fork join are required to finish first. And as you can see at the output, that first thread A finishes at time 10, then the thread B finishes at time 20, and right after that, when all of the threads inside the fork join finish, then only the main thread executes or finish at time 20. So that's how standard fork join works. So let's do a little modification, and let's show you the behavior of the join any. So what I will do, I will just write any here. So now we are using join any. So this tells the simulator that block the main process until any one of these threads finishes, and then let the main process continue. So what will happen? So if any of the thread finishes first, so let's say if we have more than two threads, even four threads, five threads, if this thread, that is thread A, finishes first, then it will not wait for other thread to finish. Instead, the main process will shift out of this uh, fork join block, and it will execute anything outside it. So in our case, first the thread A will execute, and right after when it finishes, the main thread will execute. And after that, in the at the 20 time units, the thread B will execute. So let's find out. Since I made changes to my code, I will compile it again. So let's start the simulation. As you can see it right here, that first the thread A finishes at time 10, and when it finishes at time 10, right after that, the process leaves. The process leaves the fork join block, and then it moves to line number 15 because this particular line has a delay of 20 time units. So it will wait, and then it moves to line number 15 and it executes the main thread, as you can see it right here. So right after the thread A, the main thread finishes at time unit 10. And after that only, when the main thread finishes, then 10 more time units later, the thread B finishes at time 20. So this was the difference between uh, the join, the fork join, and the fork join any. So the fork join is blocking concurrency construct in which all the threads are required to finish. Then only it will proceed to the next line after the fork join block. And the fork join any in this particular block, it remains blocking until any of the thread inside it finishes. And if any of the thread inside it finishes, then it becomes non-blocking. And whatever is written outside or after the fork join block, it will start getting executed. And then we have a blocking one, which is join none. So inside fork join none, the thread will not wait. It will not wait for any, the process will not wait for any of the thread to execute completely. So this is non-blocking. The main process schedules and moves on immediately without waiting for anything. So what will happen when you will start the simulation? Since we don't have any delay before line number 15, this process will, the main thread will execute at simulation time 0, and after that only the threads will start executing. So without any further delay, let's compile the code and run the simulation. Run the simulation. So as you can see it right here, the main thread resumes or finishes at 0 time unit. It does not wait for any of the thread to finish first. And it is because of the fact that the join none is non-blocking in nature. So the main thread finishes right away, and then after that only, with respect to their delay in time units, the following thread proceeds to finish. So first the main thread finish, as you can see it right here. Then the thread A finishes at time 10 time units, and then the thread B finishes at 20 time units. So This was the difference between fork join any, and fork join none. So I hope you find this video useful and stay tuned for more. Thank you so much.